Okay. In this video, I want to go over two things. First, solving radicals, and then second, graphing. So remember, when solving radicals, it's very similar to when we solved equations. Namely, it's kind of similar to when we solved quadratics. Remember, we used order of operations backwards. And I want to give you an example of a quadratic to sort of mock this example, but this one has a square root. So if this had, let's say this problem had said x squared plus 3 equals 7, and they asked us to solve it, we would say, okay, we got to get x by itself, or we got to get x squared by itself. So we're going to subtract 3 first, and we say x squared equals 4. That was our first step, undid the addition, right? And then we said, okay, how do we undo a square? And you all learned, oh, you got to take the square root of both sides. So we took the square root of both sides, and we got x by itself, woohoo! And then this was plus or minus the square root of 4. But we know the square root of 4, it's 2. So this was x is plus or minus 2, and we were done, right? This was your answer. The idea is very similar for solving radicals. The steps will be identical. The only difference will be at the very end here, instead of taking square roots, we'll need to square both sides. So notice in this example, I have square root of x plus 3 equals 7. I want to get the square root by itself before I go squaring anything. So we got to undo addition by 3 by subtracting 3. So these 3's cancel out. Now notice my square root's all by itself. It's happy. So the next thing that we're going to want to do is, okay, how do we undo a square root? Well, if we look at this example over here, the way we undid a square was taking a square root. So in order to undo taking a square root, we're just going to square both sides. In other words, raise both sides to the power of 2. So that will take the square root and the square and cancel them out. So you get x all by itself. X is happy. And now 4 squared is 16. So your answer is x is 16. Notice it's not plus or minus 16 because we didn't take a square root. So our answer is just 16. Let me work out something similar, very similar. I'm going to erase this. Just to show you a difference here. What if the problem was given to us a little bit differently? What if our problem said this? What if it said the square root of x, x plus 3 equals 7. So what if our problem said that? How is this different from this? And hopefully you see right away that here the 3 is outside the square root, and here the 3 is under the square root. When there's a number with x underneath the square root, you have to square both sides first before doing addition and subtraction. So you have to square both sides first. And so why do you have to do that? Why can't you just subtract 3 from both sides here? And the reason being is that 3 is underneath the radical. Like we have to bust that radical in order to get to that 3. So the way we bust through the radical is by squaring both sides. So if I were to continue solving, we would subtract 3 from both sides, and we'd get x is 47, or sorry, 46. So notice, I mean, it's two completely different answers. So I wanted to point out that difference to you. Okay, so the next example I want to give you is what happens when there's a square root on both sides? And the answer is a little bit actually, in a sense, a little bit easier. Okay, how do we get rid of a square root? We have to square both sides. So now when you square both sides, the square root and the square cancel each other out. So basically you've busted this x plus 9 out of that square root. So you got rid of it. So again, x plus 9 equals. Here, on the other side, on the right, okay, we squared both sides, so the square root and the square cancel each other out. That means we busted the 2x plus 4 out from underneath the square root. Sorry, this technology is not working very well. Okay, perfect. So we've busted everything out. Notice, it's very nice when you have square root on both sides. Notice, all we did basically was we removed the square roots symbols. But the reason why we were able to do that is because we squared both sides. So then you solve this just like you would an equation. I have x plus 9 equals 2x plus 4. So you have a letter on both sides. Let's take care of moving the letters first. So I want to get my x's all on the same side. So here's my x on this side. If I want to move it over to the right, how do I do that? Notice this x is positive. So to undo, so we could think of it as like plus x. So in order to undo positive x, I will subtract x from both sides. And if you want, you can put the little 1 in front. Not necessary though. These x's cancel, so I'm left with 9 equals 2 minus 1 is 1. And then we have our x. And then bring down the plus 4. Okay. Next, we have our x on this side, so we might as well move our 4 to the other side. So how do we undo plus 4? We're going to subtract 4. So it's going to be 5 equals x. So the next example I'm going to run through is going to talk about graphing radicals. Before we start graphing radicals, I just want to review with you sort of what the form of a radical is. So it has the form y equals a times the square root of b times x minus h plus k. And I just want to remind you of a couple of things. Is a reflects if it's negative. So plus a reflects over the, negative a reflects the graph over the x-axis. And positive a is just exactly what the parent is. We'll give you a graph that looks more similar to the parent function. The b would be horizontal shifts and reflections. H, remember this moves you left or right. And whether you move left or right depends on what h is. If h is positive, remember plus h moves you left. Sorry, that looks terrible. Plus h moves you left. So plus h moves left. And minus h actually moves you to the right. So these do opposite of what's there. And then the last part is the plus k part. So this moves you up or down. And that's going to do whatever the sign is. So plus k moves you up, minus k moves you down. So remember, h was the one that we had to watch out for. Before we go into an example, I want to remind you that when you're graphing, I want to remind you the parent function looks something like this. So we're looking at square roots. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2 would be a decimal. Square root of 4 is 2, and so on. So we get a graph that looks something like that. Just want to remind you of what this parent function looks like. This is what the parent function looks like of the radical, or the square root. So let's look. Oh, one more thing before we go on to an example is the vertex. Remember, the vertex is the point h comma k And we talked about h and k up here. So h, just remember, h does opposite of what's there. But so we'll use this to help us graph. So let's look at this example here. So y equals the square root of x plus 4 minus 4. So I like to graph my radicals starting with the vertex. There's a lot of ways that you can approach graphing these, but I like to start with my vertex. So, whoops. So here's my grid. This is my graph. So I know what the vertex is h comma k. Remember, h is the number inside the square root with the x. So what number is inside with the square root? Is 4, but it's actually the opposite of 4. So remember, it does opposite of what's there. So instead of 4 moving you right, it moves you left. So that means our h would actually be negative instead of positive. And then our k is exactly what's there. So our k is negative 4. So remember, h does opposite, k does the same. So I could go ahead and plot this. So I'm going to plot the parent function and the new function so you can see it. So here's what the parent function looks like. Yeah, this is just a sketch. So here's where I'm going to plot negative 4, negative 4. So 1, 2, 4. You'll have to forgive the graph is a little bit crooked, but you get the idea. So here's the point negative 4, negative 4. The last thing I'm going to do is I'm going to look at the a value. The a value is going to tell me, do I need to flip my graph over the x, such as this? So if this is if the green is my parent function, then what if I were to have a negative in front of the square root? So if I were to, so the green is square root of x. The purple will be negative square root of x. So it's just reflected over the x. So which one of these cases do I have? Do I have a positive in front or a negative? And in this case, I have the number out front here would be a positive. So I'm just going to sketch it to be something like that. It doesn't have to be totally to scale. Just a good sketch will do. So this is a good graph of your function. You don't need to include the parent function there. I included it so that we could see it. The next thing they want is the domain and range. So the domain and the range. So let's look at our function. Remember, domain has to do with the x-axis. So remember, x-axis goes left and right. So how far left does this graph go? So let's see. We go to negative 4. Do we go beyond negative 4 to the left here? And the answer there is no. We actually stop at negative 4. We have a closed circle at negative 4. So we could notate this as negative 4. And then notice we have an arrow on this graph. It means it keeps on going to the right forever. It's never going to end. So this is negative 4 to infinity. And remember, infinity always gets a parenthesis, never gets a bracket. The range has to deal with the y-axis. So this is how high up and down your graph goes. So if we start over here at the vertex, does our line of our graph shoot up or does it go down? And I hope you can see that the line goes up. It goes up not steeply, but it does go up from the vertex. So what is this point on the y-axis? Well, it's negative 1, negative 2, negative 3. It's negative 4. So our range goes from negative 4. And this graph keeps on going up. It's not going up, like I said earlier. It's not going up very fast, steeply. It's not going up very fast, but it is going up. So eventually we would get to y values that are way up here. So we would say it's bracket negative 4 because it's points included all the way to infinity. Okay. I want to give you another example of graphing. So the next example is this one. So this is number 20 this is actually from your homework. Y equals 5 plus the square root of x minus 4. Notice It's a little different than 17 in the sense that in 17, the square root came first, and actually in most of your problems, the square root comes first. We want to rewrite this if the square root comes first. So the way we're going to do this is we're just going to switch spots with the 5 and the square root of x plus 4. In other words, we're just rearranging the right side of the equation. So instead of having 5 plus square root of x minus 4, I'm going to put 5 plus, I'm going to put square root of x minus 4 plus 5. And this is more familiar to what we've seen, like what we saw in number 17. And then you could say, well, my vertex would be very easy to identify here. It's going to be the opposite of this h value, so it's going to be 4, and it's going to be this k value, 5. So if you graph it, here's your parent function, square root of x, and then the transformation. Sorry, I should have done square root of x in a different color. But our new vertex is 4, 5, so I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 5. I'm going to put my dot. And this has just moved up and over here since a is positive. And then you're going to have to answer the domain and range questions. So this is how you would want to approach number 20. As always, if you need help, please reach out to me via email, Google Classroom, or Remind. I'm there for you. Hopefully your week 5 goes well. And I look forward to hearing from you if you have any questions.